All right, well, my name is Eric Lynn. I am with Lutron. Been in the industry for several years. My hope today is we'll touch on something that's starting to happen in the industry. Color in the world of what we live with today is not necessarily that new. How many of you have a dimmer in your house with an incandescent or a halogen lamp? So the idea of color change is something that we actually experience in our homes. Certainly we deal with it as well with the sun every day. The sun doesn't really fundamentally change. Obviously what it passes through as far as the atmosphere and the sky. So I want to touch on something that's new to the industry. Again, color in terms of color in spaces has been around for a long time, but we're now moving into a world with the idea of the general lighting, what we live with every day, is actually starting to be a part of what we have to commission in our buildings. So this is a AIA course, is registered. This is their backup material that I need to show you as far as part of the continuing education series. Material was created by us. And the things that I want to focus on are just some background on LEDs. Certainly it's a unique source in the sense that unlike virtually every source before LEDs, it does have the ability to change, and that has with it some things that we have to consider. The other part of this is that as we look at the idea of color tuning, there's some things that you need to consider that will hopefully eliminate mistakes that are already being made today about how to set up the systems. I talk about here the idea of a sequence of operations. We think about a room like the room right now very simply, that we walk in the room, there might be a switch at the back of the room. In the world of code, there may be an occupant sensor that turns these lights on automatically when we walk in, or turns them off automatically when we walk out. But as we start to deal with color, it's a little bit more complicated because we have to start to think about two things. Do I want the color in the space to actually change based on time of day? Do I want it to be able to be changed by any of us if we were the actual person living in that room for that minute? It could be a patient room, it could be a home, it could be our office. And at the same time, how do I go from one color to the next? What should that experience be? Should it be smooth and continuous? Should it be somewhat rapid? Those are all part of things that we have to think about to make sure the system actually achieves what people want. And then the last piece of the conversation is the new well standard. So we've been in a world where buildings have had certain dictates to them in terms of what they need to do to make the building a better performing building, both from an energy standpoint and from an occupant standpoint. In many regards, LEED, I believe, started down the path on energy first, occupant second. It had an occupant focus, but clearly WELL takes it to a much higher standard in terms of bringing the focus on the people inside the building. So let's jump into some of the components of this. One of the big elements about color temperature is cool versus warm. This isn't probably as clear as it should be, but the idea here is that what you see on the screen is that you see what we have maybe in our homes, a warmer light when you dim versus a cooler light that might be anywhere from 5,000 to 6,000 Kelvin. Natural sunlight for most of us is in that 5,000 to 7,000 range. Very white light, but what we see in our homes, again, with an incandescent lamp is much warmer. The idea here is that I can be anywhere in between based on preference, but we also see that variation occur naturally in sunrises and sunsets every day, and it gives us an idea of kind of what's happening. Now we have a chance to actually control it. If you look at this from a bit of a scientific side, the outside that's running around on is the actual wavelength of the light. Not that important necessarily to know, but it is something just to be aware of. The really important piece is that when you look at a chromaticity diagram, the numbers on the inside are what make up that color temperature. and we use it as just a reference. So most of the incandescent lamps that you have in your house are in that 3,000, 2,700 Kelvin range. For the most part, if you have a home, that's the one number you should know. If you work in an office building or you work in a complex that has any kind of fluorescent lighting, good chance you're closer to about 3,500. So what you'll notice is that we don't really get into those higher color temperatures with most of our spaces today. And part of it's because of a belief that the color temperature we prefer is in that lower 2,700 to 3,500 Kelvin range. So some different types of tunable dimming. The first one I mentioned to you, your incandescent lamp, is an example of warm dimming. So I'm taking a space and I'm taking it from one temperature down to the next. This is built into the source itself. So a tungsten filament actually changes how much color will actually emit based on the amount of power being put through it. So at full light, it's going to be at one temperature. As you dim it down, less voltage, less power, it's much warmer. Control on the wall operates it. You don't need to worry about really anything other than the fact that you need a device on the wall to control it. In the world that we're living in with wireless, you're starting to see that that device might just be a switch, and everything that you might choose to do might be an app on your phone. Same basic idea though, the actual control of that is really within the lamp. So one has a voltage control coming to it, the other might have the ability to actually send a wireless signal to that lamp. But that's pretty much of a pre-built curve, not a whole lot of complexity to it. All it does, you can see where its starting point will be, which is down in that range. Starts around 3, and as you dim it, it moves down and down further. Now, tunable white's a little bit different. Tunable white needs some intelligence. It needs some level of people making a decision what kind of fixture to use, what kind of control system to use. What we'll touch on are those considerations, because there's a consideration in the ceiling, which is what type of color am I mixing? I'll call it the ingredients, for lack of a better term. What's in the fixture that's going to give me a certain level of color and color control? And then on the control side, it's how am I controlling it? Is it a very straightforward 0 to 10 volt signal, or is it something more digital and more capable? So we'll start with the fixture side of it first. So what's happening with this idea of tunable white? I talked about the fact that we've had this in our lives for a long time. One of the big components that's driving this is we have more and more people spending time indoors. We want to find a way to potentially mimic daylight. We're not at a point in my mind where I believe we are living with enough data from the health side to know whether mimicking daylight has some huge impact on our well-being. But there is anecdotal data that people like the idea of the inside mimicking the outside. We also have spaces that have been doing this for a long time. Hopefully you haven't had to deal with working on shifts where you may have had to work from 11 o'clock at night to 7 o'clock in the morning, but there are a number of buildings around the world. Utility control centers are a great example of it, where you have 24-hour day operation, all indoors, no windows. So they've been actually doing this type of light change for a long time. When I jumped in the industry in 1985, we probably had a couple of projects within a couple of years of when I started. So the idea of mimicking daylight's not a new idea, but we're just starting to get more and more people that are thinking about what they can do with that. The other part about flexibility of space, sorry about that, the middle one that I like is this is the idea that if you had a color temperature coming out of your light and you want the room to look a certain way, you may not know what the paint color was going to be or the carpet was going to be when you design the lighting into the space. So all of a sudden someone goes from this tan or brown color to changing it to a different color, maybe a much darker color. We might want to change the color of the lamp to be able to help the room stay a certain way, a certain look. So it gives you a flexibility to be able to change that based on the decor. That's a little different than mimicking daylight. It's really more of a style, but it also is appropriate because if you have a desk in front of you and you want to get a certain amount of light on the work surface for you to take notes, to work on a computer, to have a meeting, the flexibility of space allows me to adjust the light that if I had darker walls in this room, the amount of light potentially on your work surfaces might actually be different if I didn't make an adjustment to those lights. So if I change it from a tan wall to a black wall, I might actually have to increase my light and potentially my color temperature to make that work. And then the last motivation is the one that we all have a certain preference, whether it be the idea of being in a car, the temperature in our car, the radio we choose to listen to, personal preference, same idea, people like the idea. I'm going to show you an example a little bit of a patient room, and it was very much about finding out that one of the things that they believed helped with patient outcomes, and this was actually proven, was their ability to control their environment, and that was primarily, for a long time, just temperature. Now we're actually giving them control of the artificial light as well as the natural light, potentially automated or in some cases manual. It doesn't have to be a complex system. And that personal control had a positive outcome for those people. So the first place that most people think of today is, this is pretty cool. I can just have a really warm 2700 Kelvin fixture, and I can have a 5000 Kelvin fixture, and I'll just mix and match anywhere in between. So I mentioned some of those control facilities that we started doing. That's what a lot of them did. They would have fluorescent lighting that was fairly cool, incandescent lighting that was much warmer, and they would just mix and match based on trying to replicate an 8-hour workday. So in this case, I've got a warm and a cool strip of LEDs. It could be inside a downlight, which is most of what's in here, or it could be a linear fixture mixed inside that fixture. So you obviously have the warm on, it's going to be warm. When you have the cool, it's going to be cool, and then I can mix anywhere in between. Straightforward. Now, you start looking at that, some people will say that wasn't precise enough, and I'll show you an example of what happens when you just do 2 points. People would say, let's mix red, green, and blue, because I might be able to get more precise with the color temperature that I want. The challenge is, as you add more variables, right, your setup time increases. In this room right now, when I had to look at dimming this room, I really only have a couple of zones. I probably have wall washers and I have downlights, so I have 2 zones. When I start to increase the number of colors inside each of these fixtures, my 2 zones now go to 6. And you can imagine a whole building that has different rooms. Obviously, this has a whole array of meeting spaces. This may have been as simple as 50 zones on this floor or this section of the building, and now all of a sudden it might go up to 150 or 300. So again, same thing, we change. Red is going to be my warm output, and then I can maybe even add 2 more, go to 5 different channels and mix and match. All these things start to make sense. So what do I have to worry about? Well, I mentioned to you the first place you start with is the idea of 2 different colors. And you can just mix and match. All right? Seems straightforward. But one of the things you're going to find is that it may very well seem simple, but as you start to put it in motion, it's a little bit more challenging. Now, that being said, I'm not trying to poo-poo the idea as much as to make people aware that sometimes the lowest cost solution is going to require more commissioning time. And let's show you an example of that. So first off, it really puts you in a situation where it doesn't really give you the highest quality light. The highest quality light is like the sun. We talk about colors being rendered accurately. The sun is beautiful at it because it has every color in the spectrum in one source. Fundamentally, an incandescent lamp also does the same thing. Fluorescence did not. Most LEDs do not. So what you get into is, instead of them being along that curve, which is really that highest quality of light, they take a shortcut. So when I look at a space, and let's say I want to get to a certain color temperature is on the bottom, and my light level is over here on the left, and I think of it from a standpoint of mixing these two. I've got my warm control on the left and my cool on the right, and I bring it up, and I got to keep adjusting these fundamentally to get to a point where they're the right setting. Now, if all I'm doing in a space is presets, so I had buttons, this would be easy because I could set up 3 or 4 different presets to get to the right level I can mix and match. The challenge is that that's a single point. If you've ever tried to do controls, most people when they do controls, it's not the same intensity. Just focus on intensity for a minute all day long, right? If we have a control on the wall, we like to actually adjust it. This room may be used for a wedding versus this type of AV presentation, and how you want to light it's very different. So statically, I can do this, and I can do it pretty well. But now, if I start to think about having these at those 2 levels, and I want to adjust them and dim my lights, and I slide them, all of a sudden, the color temperature that I thought I was going to be at has changed. So the ability to stay at that proper color temperature becomes much harder. If I do those presets I talked about, I think about 4 different presets at a certain temperature. I've got to really almost program in 12 different settings to achieve that. Now, if you think about it, the idea of presets could work, but I don't have a lot of flexibility, and in most of the codes that we have today, I don't have the advantage to take advantage of daylight, which most spaces that have windows today are required to dim. It's also a little bit harder to do time clock, although in my mind, that's something it's more difficult. It's not as difficult as actually doing some kind of manual control. So now, let's change this up a little bit and change it to being the intensity and the color. So instead of me changing warm and cool and having to figure it out, somewhat do the work behind the scenes, now what I'm going to do is the intensity, which is the light level, and I'll change the color. And what will happen is inside the fixture, just like your incandescent lamp does today, it fundamentally does the color mixing for you. So you're buying a more intelligent fixture that has the ability to do the actual color mixing, but you still need really 2 channels, one for intensity and one for color. So again, the benefit now is that I am going to stay on that curve much closer. I'll keep the quality of my light much better. And then when I look at it from an application standpoint, if I want to reach that point, I've got my 2 sliders, intensity, and color temperature. So I can dial it up very quickly. I don't have to do any kind of variables. The other benefit of that is that once I've set that color, it's much easier for me to stay on that color because I'm only affecting the intensity up and down, right? So if I want to be able to say, I've got my room at 3,000 and I can go from 100% down to 1%, this approach, far more effective. Again, more expensive, obviously more expensive than what you would face with a cool and a warm, but it will allow you to configure the system much faster. Can't give you a percentage, but I would tell you more often than not, it's probably in the range of something like 50% faster because you don't have to go through the exercise of actually configuring what you want set up. So, taking color, we want to achieve flexible spaces. My first approach is warm-cool. My second is a more intelligent approach of intensity and color temperature. I now have the flexibility of manual control without affecting the quality of the light. Again, the nice thing about most of what we know with dimming today and control is that more often than not, Either we wanted a predetermined curve, we wanted the lights to get warmer. Restaurants, your home are all places where we like the idea typically of lights actually changing, getting warmer, but I may still be in places where I want that to still be the same. So I'll give you the example. I have a room that I want to be able to have it change based on time of day. So I want it to actually match the sun. So at 8 o'clock in the morning, I want it to be a little bit warmer, and it gets cooler the rest of the day, and then it gets warmer again at the end of the day. But the intensity of the light in my room, we're all different. You know, how much light I like is different than somebody else. So if I can actually have it changing automatically, but I can manually override it whenever I choose to from a keypad or, again, from an app, I'm giving that space the ability to have automation without losing the individual personal touch that you may want. And again, that hospitality example of a guest room or a hospital example of a patient room are both very good examples of where you would want to see that same kind of capability. So I mentioned the time clock, and why is that so important? Well, the big part about it is that if I want to achieve these different levels of intensity, and I want to be able to start in the morning of the day and actually change it, the nice thing with the time clock is that it's all pre-programmed. How many steps you put in there is just a matter of choice. You could see on here that we probably have in the range of about 7 or 8 steps. More often than not, most systems out there today would have some level of ability to have a fade built into it to make those transitions as smooth as what you would typically see with the sun's change in the sky. All this is really showing you in terms of the illuminance and the color temperatures, trying to give you an idea that I might change even how bright my room is based on time of day, right? Middle of my day, my sun's typically as brightest. It would not be as intense in the beginning or the end. Another variable that you can consider here is maybe the opposite. Maybe you think that a brighter light would help you get up in the morning. There are actually some rooms out there that are being used, developed, I should say, for hotel guest rooms where people actually want the lights to be cooler. They believe it's a more intense, more vibrant light level that might wake someone up a little faster than just doing it based on the natural cycle. So just because that's one approach, which is maybe the most common, doesn't mean you actually may not want to alter this to be able to be brighter, faster, to help you get up in the morning. So the comparison between those two we've already talked about. I think the other element of a lot of these codes is that most codes that we've dealt with in lighting control systems in the past were as simple as aux sensors initially, and then aux sensors and time clocks, and now daylighting. It's important to know that any consistent system out there today has to take into account whatever codes may be. So in the state of California, the codes are going to be more strict on energy than pretty much every other state that we deal with. I should even know what Nevada is today, but I'm not sure I know. Not that everybody's from Nevada, but it is something that you'll ultimately have to implement, whether it is a color tunable solution or a traditional static color temperature solution. Now, I mentioned before color temperature and why that's important. The consistency is something that people like. We all like to be under a good light. Whether you're shopping for clothing, whether you're actually out at a restaurant, nobody likes to be in a situation where your skin temperature or what you are working on, your food that you're about to eat, does not look right, right? Color makes a difference. So a big part about that color consistency is trying to be as close to that curve as possible. And again, it's an important consideration because the further off you get, the more sensitive. It doesn't mean it's as critical in every space type as we deal with today. A good example is people were willing to work with fairly poor lighting when it came to parking lots. We've all driven into parking lots that had potentially a yellow light, mercury vapor, or even a high pressure sodium that may not have even given you a sense of what your car looked like, right? Maybe you couldn't find your car sometime. I know I've dealt with it once or twice, and it wasn't because of color, for other reasons, but it is something I've had people tell us is an issue, that's something that be a concern. But you move into a restaurant, you move into a hospitality space, you move into your home, and again, the consistency of the color becomes very critical. It's the last thing that we want to do is compromise that and have people not like their lighting because the color doesn't render food or doesn't render the people in the space very well. So I mentioned before that the first thing was the options of either warm and cool or potentially multiple colors and then having intensity and color temperature separately. How we control them becomes fairly important at that point. So most of the spaces that we're in today, the best way to describe them is probably the same thing for your house, is everything wired together works together. So if you had a couple of downlights over your kitchen counter, they were all wired together and they went back to one switch. All right? And that one switch could either be a switch, or if it was a dimmer, it was a dimmer, and you could dim the lights. Probably the most common protocol out there today, because it is relatively inexpensive, is 0 to 10 volt. It follows the same rule. Everything wired to that same set of 0 to 10 volt wires operates together. All right? The challenge you get into is that as you get into different inputs in that fixture, the 0 to 10 volt, which has basically a voltage and a common, 2 extra wires, I now have to potentially send 2 of them to every fixture. So I now have 4 wires on top of hot and neutral. Again, it may not be something that I'm showing you on the screen, but it's basically going to increase your number of wires because I'm increasing what I have to put to each fixture. The more likely option would be to start considering some of the digital versions. Dolly maybe being one that's most common. It is a 2-wire wire bus, but on those same 2 wires, I can have multiple zones. So unlike 0 to 10, which would have to run 2, if I had just 2 channels, just warm and cool in that fixture, I would still only have 2 wires with Dolly. Now imagine if the fixture went to 5 channels in that fixture. You probably would never even consider 0 to 10, but that's also where you start to look at something like DMX, because DMX is a theatrical protocol, but you're starting to get to more channels as far as an option. The last one on the list, wireless, is coming. It's already there. Wireless control's been around for quite some time, but wireless in the fixture and allowing you to have variability of different channels or an intensity and a color temperature is just now starting to unfold. Good news is wireless takes that wiring dynamic of 0 to 10 versus Dolly or DMX off the table. The challenge will be that wireless in some cases may have some limitations in terms of how many wireless fixtures you can actually use on a given system. There may be some limitations of range in terms of real estate. But it's an important consideration because it's also going to have an impact on commissioning. Because the commissioning time, in some cases, one of the biggest things that we see in systems today is that more often than not, as you get into a building being constructed, it has to be wired to be able to get commissioned. We always jump to the fact that everything the contractor was supposed to have done was done by the time we show up on the project. It's not always the contractor's fault. I'm not here to lay blame on anybody. It's more a matter of construction timing that things have to get wired. In many cases with wireless, one of the things that you also can eliminate, though, is you don't have those extra terminations. All you have to do is get power to the fixture, and then you'll be in a position to be able to start doing some of that commissioning. So, when it comes down to the idea of full spectrum control, I've been talking about intensity and I've been talking about the idea of color temperature. You actually will start to hear about some other variables like saturation and hue. I haven't presented them here because to me they're elements that kind of aren't ready for prime time, but there are people that will also pay attention to them. So that's 2 more variables to add into the mix. I don't think they'll be as critical and on as many projects, but they are part of what people talk about achieving full spectrum control, is to have all those options built in. So sequence of ops. I mentioned this is a critical piece. It's something that we look at for every system today. The control side of the industry looks at it as well. Documenting it up front helps everybody in terms of what's required. Estimating time to commission it, estimating time to train the end user on the system. So a big piece of getting into it is thinking about these elements, right? So the first one is the programming side, which is what do I need to know as far as codes? It's the first thing. What do I need to know as far as integration? And what I mean by integration, again, is to sensors, could be AV equipment, could be residentially, it could be a sound system. It wouldn't really matter, but those are all things that may get plugged into the lighting. And then we also have to consider what's going to happen in the space. Is it a personal preference, or do we have to design for the masses? So we're going to design a system, program it based on what we think is the day-to-day use. Think about time of day. Don't just think about one operation, one time. The other element is to sit down, I think, with the end user. I think the biggest thing is, too often than not, the end user doesn't worry about the narrative until after the system's commissioned. And what we find out is they didn't quite like how it was set up, and we have to come back. It may have been planned. You may have already built that into your commissioning fees or built it in your commissioning timeline. But it certainly helps to go down the path of trying to get the end user involved earlier. We've seen a nice change with a lot of the larger corporate clients that are building some larger spaces, 100,000, 200,000 square feet and above. They're doing a better job of it. They understand the value of getting those types of interviews with their employees, especially if it was a past space that they were living in and now they're moving into a new building. What were some of the things that worked? What were some of the things that didn't work? And how can we fix that moving into the new building? And then last but not least, looking at everything in terms of every way the system could be operated, manually, time clocks. We also want to think about locations of devices. And this is going to sound crazy, but so many people today don't think about engraving. Most of the devices that we have today, unless it's a single button device, like something that's on our smartphones, our TV remotes, our microwave ovens, they all have labels. A lot of times as you get into these systems, people don't take the time to actually label them, and we end up playing a game of kind of guesswork in terms of figuring out what are we actually looking at with the system, and all people do is keep pressing, and if there are any kind of delays, any kind of sequences built in, they bypass them because ultimately they're not going to give it time to actually happen. We've actually seen people go down the path when they move into a new building, even if this was a renovation that you were working on versus new construction, actually putting labeling on an 8.5 by 11 just to walk people through what's happening in the space so they get educated and are not surprised by it. So we saw this already before. Again, now we're tying it to a time of day. And you can start to see some of the things that we may have to do if we had warm-cool. That may have to follow a different cycle of programming than if we had intensity and color temperature. Again, both of these have to be programmed and planned. Setting up the one on the left will take more time than setting up the one on the right. This one's much more about what's my preferences. I can pretty much dial it in instantly. The one on the left, you'll actually be playing around a bit to be able to find the right mix in terms of intensity and color temperature. So when I'm looking at presets, if all I'm looking at are presets, either one of those options may very well be a viable option. I build this in, and no one has the ability to worry about variability. And if that's what you want to do, it works. Right? You're locked into 4 presets. It's like your presets on your car radio, and you don't worry about anything else. But most car radios typically have some type of variable tuning. You don't get 4 options and 4 options only. So just make sure that if you're a locked-in space to presets, that you're not going to have people pushing back that they wanted some ability to vary the light levels. The most common applications for this are public spaces like here, where we've got a lot of people and we have to come up with what's the presets that work the best for the most largest mix of population. Something else to consider, which is it's programmed. I mentioned before the override. We choose to dim the lights below where they currently are. Have we answered the question of how long that override should last? Right? Should it last for an hour? Should it last for 2 hours? It needs to be thought through. Back to that sequence of operations. It shouldn't last forever. And it's a situation where that may very well be a variable that you also have to consider during commissioning. I mentioned before this limitation already, which is can I adjust the color and only the color, or can I adjust only the intensity, and which is going to be a more acceptable variable for the end user. If they're adjusting both in that warm-cool, they may not like it as much because the color may get a little bit off. So, some measurement considerations, and I'll just throw these up on the screen. These are details that I think are just some things to consider when it comes to programming. So one of the first things that should jump out at most people, which is I've set up, and I'll take tropical or I take the other meeting rooms, I've set up 8 rooms. How do I know that I'm actually at the right color temperature? So there is gear out there today. There's different types of meters that you can use, different quality like anything, that would help you at least to know the color. More often than not, one of the things that we like about individual fixture control is that you'll actually be able to measure each fixture versus the room, because there might be some slight variation between each fixture. The other thing to consider is that when you're doing your calibration and you're doing your setup, if the space needs to be daylit, it's potentially harder when you're trying to do that on a room level, because most daylit spaces only affect the lights that are within a certain distance from the window, and they don't necessarily affect the entire room. So setting up these systems, a lot of times verifying the light levels and verifying the color temperature is an added step, and again, the big thing is having the right gear to be able to do that. Don't just always trust your eye based on where you think the color temperature should be. So as we look at different spaces, here's a patient room. We're talking about patient room that's got several different areas to it. So it's got a staff area, it's got the patient room, patient area by the bed, and it's got the family area as well as the bathroom. This is how the room potentially is configured based on the presets in the room and based on the time of day. When I then go one step further, I'm going to now look at, okay, my daily cycle, what do I want to achieve? I want the color temperature to change throughout the course of the day. I want there to be a fade, right? An adjustment that happens over a certain period of time, and we're going to pick 90 seconds. And 90 seconds is a bit like the passing cloud syndrome of what we have with sunlight today. When the sun dips behind the clouds, there's a certain period of time that your eye adjusts. 90 seconds, more often than not, is beyond that, and people may not even notice that the actual change is occurring. And then back to that override, if somebody does make a change to how it's configured, I want to have it stay there, and after an hour, revert back. When I look at that entry area for the staff, they come in, you want the lights to come on a little bit faster, right? None of us want the lights to take 90 seconds to turn on. So we want the lights to come up gradually. A 10-second fade is not too abrupt for the patient in the room. Similarly, I want the lights to actually fade to off. Again, not to be abrupt. If the patient was sleeping, in this case, potentially the staff can come in and out without it being disruptive. So here, I want the lights to go to full. I need as much light as possible. I have a certain patient requirement in terms of measurements, whether it be taking a temperature or something else, and I need as bright a light as possible, and 5,000 Kelvin potentially would give me that light level. Day check would be a time, again, to come in and just do a nurse drive-through and verifying the patient is doing okay. Night check, similarly, Big difference would be I want the lights at a much lower level. Good chance in this same hospital, again, they've also got the hallways also being affected. It's not completely tied to lighting, but we actually have had projects where you've had situations where the nurses' stations, where they would congregate, would get loud, right? There would be a number of them talking. They actually had audio sensors that would pick up on how loud they were and automatically dim the lights around the nurses' station to remind them that it was after a certain time they needed to be quieter. But those same types of spaces now have the ability, again, for those hallway lights to go from being a cooler temperature, maybe that 4,000 or 5,000, to being more like our residential. And it allows it to be less of an impact when the bleed light comes into the room. It's at a much warmer temperature. And then the last thing to consider is, again, the patient option at the bed. What do they have available to them? It could be a situation where it's not just the lighting, it could be temperature, it could also be shades. All those things could ultimately be integrated out of control. We actually have hospitals today that are starting to have people bring their iPad or mobile device with them, configure it so they can actually have access from that device. So the devices on the wall, the engraving, talked about that as well. All of it comes into play. And then where are you going to put those devices throughout the room? Again, you may have a situation where these devices, not just the fixtures being controlled wirelessly, but these could also be wireless, which means that you also have a bit of the option that if you locate them to start and you find that that's not the best and most optimal, you actually can relocate that as well. So, talked about a bunch of these. Light levels, color temperature, those are really the big elements of what we want to do with commissioning. Scenes, the ability to have daylighting. Some other elements are all of these other pieces, right? Things that have an impact on how the room is actually going to be configured. I didn't talk at all about visual communication as much as maybe I should have, but we have a lot of corporate office buildings. Some of you may have worked in a building that has this, that you're working after hours at 7 o'clock at night, and all of a sudden the lights would blink. It was a warning they were about to be cycled off. If you walk over and you touch the keypad or you hit a switch, you'd have a certain override built in for typically an hour or 2 hours. All right? So all of these come into play, and now you get into where are they going to go, what kind of building, and what building guidelines are being given to you, and that's where WELL comes into play. So WELL is relatively new, but it's something that's getting a lot of pickup. It was really being driven by an entity named Delos, and a lot of this goes back to this focus on people in the building, how much you spend on energy versus rent versus people. And the idea is that the orange, which is 90%, I've seen other numbers out there before as well. I've seen 330, 300, but it's a similar scale, which is that fundamentally the cost of operating the building is much less than the actual cost of the people inside the building. So Delos is focused on this. It is focused on these elements from new buildings to existing, as well as to a core and shell. How it comes into play with lighting is that you've got 7 different components of WELL. So there's air, water, nourishment, light, fitness, comfort, and mind. I can let you read those, but light is obviously where we're going to be focused when we're thinking about Tunable White and its impact. And those elements are lighting that's tied to activity-based lighting, so that it is really the right light at the right time. It's intended to focus on not just one light level in a space, but the ability to do multiple. Color quality we've talked about. Daylighting, obviously it's a code requirement, but it's really important as you bring daylight in that you also can then focus on glare control. And that may not just fall on the lighting system, it may fall on other components within the building design, but certainly lighting in the building can be a factor. Circadian design, and then visual acuity. And visual acuity is really the idea that the light's got to be the right light, but I also have the ability to have contrast and be able to work at my desk or meeting space, whatever that may be. Some components, much like LEED, it has some different levels, and you can see as you meet more of the conditions, both preconditions and optimizations as they call them, they will then impact your ability to actually meet the standard or exceed it. Another element of this is that it does have a certification process and a recertification process. One of the things that I always thought that LEED didn't quite achieve is that LEED fundamentally allowed you to achieve a certain standard with a really good game plan. It'd be like saying that you were a Super Bowl team and you should have won because you had a better game plan than the other team. WELL is starting to at least challenge that you have to get certified to have actually implemented what was designed. And that's an important consideration. So LEED in theory was excellent, but because there wasn't a certification process, I think you'll find that WELL is going to get a very good pickup. It doesn't mean everybody's going to adopt every element of it, but I think it makes a big improvement. So on the light side, just talking about a couple of things, I just want to show you the language of WELL. It'll give you an idea that some of what I talked about early on, some of you in the room may have thought, there's nobody that cares about that. Somebody at least is putting it into these new buildings, and more people are looking at WELL, which may come right back around and start to make Tunable White an important part of the projects that you touch. So these are the main elements that I'll just touch on real quickly. There's a bunch of preconditions, but the first one is that visual acuity, the ability to certainly have a certain light level. They talk about 20-foot candles, but it's really focused on task lighting and the ability to have the right level for the workers. You then get into this ability to balance light and minimize eye strain. It's really a tie into glare control. A lot of what that is tied to is not just your illumination from here, but your vertical surfaces, your vertical surfaces here and their illumination to allow you to have visual comfort. A lot of times that balance between the walls and their illumination and a computer screen is a very important piece of eye strain control. The circadian piece, the idea here is that they believe there's a connection to being vibrant, to being biologically active, so that this will keep people as productive as possible. The intention here, again, is to focus on changes throughout the day and the ability to affect the daylight. They talk about melanopic light, and that gets into this idea of, again, mimicking the outside. You may have heard about the whole idea of the melanopic cycle and how it's impacting your sleep. It's also tied to that, because typically that higher color temperature potentially can trigger that. So the intention here is that as I get into a certain level of light and its intensity, so color temperature and intensity, I potentially can have a certain level of vivid light or biologically active. Typically the bluer light is going to be more biologically active. Again, you want that to potentially be in it and immersed in it to be more active. You don't want it when you want to try to go to sleep, because ultimately it's going to work against you. That's why watching TV in bed is not a good thing. So these are just some numbers. Don't need to get into the detail, but this is some background on that. And then glare control, a big piece of this is understanding that it's not just the amount of light that you have in the space, but it's also making sure it's directed properly. So you will find that when it comes to glare control, probably equally as important today will be some type of ability to control the shades in your space, because if they can't be controlled, your largest source of light at an angle coming into a building is going to be daylight, and it'll have an impact on this as well. And then I mentioned color quality. I figured this might be the best way for you to see it. It is something that you can hopefully see the difference between the left and the right. These are real photos, and you can see that the photo on the left is taken under a light source which has a much higher color rendering index. CRI is the abbreviation. Most people that think quality light is at 90% or above. Some people have lowered that to 80, but I still think 90% is a good rule of thumb. What's on the right could actually be as low as about 55 or 60. So huge drop off from a very good color rendering source to one that does not. And again, if you can imagine yourself on your first date with somebody being under this light or this, it could make a difference. Well, yeah, maybe not always. That's fair too. So again, I threw a lot at you from one end of the spectrum, which was this idea of tunable white and why, and what are some of the things to consider, all the way through to well. And well is that, is that rope pulling people into tunable white. It's getting people excited about it. We're starting to see more of it. I believe it's going to be more on the warm dimming, kind of what you have with an incandescent built into it, because I think people like that because it's easy, it's less complicated. But that's really only going to work in most cases with, I'll call it consumer grade products. You're going to start seeing what I talked about with either two color or intensity in color in commercial. So it's important to understand what you have as far as gear. They're getting better at telling you about their ranges, what kind of color temperature can they achieve. They should also be able to tell you what their CRI will be throughout. Sequence of ops, I can only tell you the better defined it is, the better you'll be. Too many projects out there today that are being set up where the customer's not satisfied, somewhat to blame, because the customer may not have inserted themselves into the process early enough, and therefore they didn't get that sequence of ops defined. But make the time, put the time up front to get that defined. Usually what it also does is it makes a system flexible enough that if you do have to make adjustments, you can. When you don't have it well defined, you also tend to have a system that's not going to be as flexible, and there's little ability to correct a mistake. And the last thing about well is, again, it'll continue to grow. The two places that we're seeing well right now are hospitality. Hospitality is really the first place that I think is really trying to adopt it, and residential. We're starting to see a number of apartment complexes, condominiums, buildings that are multiple residential consumers living in a building that want a great environment, and what can they do to have a building that is vibrant and has other people that are like-minded that are trying to live in not just a great building for them, but also one that's environmentally conscious as well.
Thank you. Yeah, we've got questions, and so we'll use this microphone so everyone can hear the questions.
What kind of meter do you use to verify this setup?
It is basically a meter that is focused on CCT. I'm trying to think of the name of the best ones out there today. They'll probably be in the $600 to $1,000 range for color. It's not an luminance meter. It's actually a color temperature. I can find that out probably in about 2 seconds if I just text somebody. I should know the actual brand that we are using, and we just picked up a bunch, but there's other people in the industry that are using something like that as well.
Okay, when you use this meter for color, do you use it at the work surface?
Yes. Use it at the work surface. You can, in some cases, if you're doing a sampling on the fixtures on 1 by 1, you might find that it's better to be able to hold it under each fixture to verify its performance. If they're all on and you don't have the ability to actually segregate them and turn them on and off individually. So more often than not, if you're going to do it fixture by fixture, you're going to find it's going to be something that's handheld versus putting it down, because you might have multiple fixtures that you're actually evaluating simultaneously.
Sure. And then is there an associated piece with the fixture or the lighting control or the light fixture itself that you need to coordinate in order for the controls to work?
Yeah, good question. So in the case of the warm, cool versus color and intensity, typically you're going to see inside the fixture, you're going to have knowledge of whether that driver is simply a two-channel driver, and that's typically going to be an example. If it's a two-channel driver, that's usually going to be warm, cool, or they'll actually specify that it is a fixture that is a channel intensity and color temperature. There are not as many fixtures out there today that can do the intensity and color temperature with 0 to 10. So in most cases, if you're told the fixture is only 0 to 10, usually it's warm, cool. If it's a 0 to 10 and a digital signal or all digital, that's when you start to get into color and intensity being separate.
Quick question following up on the light meter. I would suspect as commissioning providers that we typically would expect the startup company or the lighting technicians who set up the lighting controls and fixtures to have those meters and provide them during startup. Is that kind of what your expectations will be, or are there any guidelines under the WELL program that will be developed?
Well, that's probably why I don't know the actual brand. It's just completely out of my mind. Yeah, more often than not, fixture manufacturer and or the control manufacturer are going to both be involved in that. It's based on really how the system is set up. So it doesn't always fall on the people that are doing the commissioning on having a custom piece of gear. I would say more often than not, I'd say 95% plus. I'd be really surprised if they did not have that within their arsenal of tools that they use to commission the system. If you're using a manufacturer's commissioning, either a direct manufacturer employee or an authorized service agent.
Do you have a recommendation as to what specification that requirement should be dictated under a normal construction process? Is it 2600?
It's under 26. Certainly the old school is under 16, but it would be under 26. And then it would be part of your commissioning language in 26. And that's where I would address the fact that if it is a color tunable system, you would actually have the ability to do verification of color temperature. I probably can get language on that too, in terms of what that looks like. It's not complicated, but that would be where it would live.
Okay. So as part of some of the points about sequence of operation, the tunable lighting seems to have a huge number of options and setup potentials. So in developing the sequence of operation, who would you expect to typically develop that sequence of operation? I don't see the owner's reps necessarily having enough knowledge to know what color temperature is or what's best.
Yep.
And in my opinion, most electrical engineers are more concerned about, circuiting and layout rather than having knowledge of that.
So what I will tell you today, that the drivers for what I'm seeing fall into one of three buckets. So as far as the individuals, I think you're after who would be the individual, the lighting design community is more often than not going to be one of the drivers, right? So if an architect's involved in a project, which is probably 98.9% of the time, there's an architect.
Right.
Electrical engineer is definitely going to be involved next. And then a lighting designer may not be involved as often, but they're the ones that will often be the ones driving that spec for a tunable capability. You said there are owners that may not be asking for it. I will tell you that we're actually seeing that there are people on the owner side focused on WELL that are driving it.
Yeah, I think they could be asking for it, but not
they don't know exactly what it is, right? So the other part that I think is an interesting element of this is actually getting down to some of the design build contractors, and that's another place where they're ones implementing this from a code standpoint. They can virtually start with a script, and it's like anything. If you ask somebody what they want in a building and it's open-ended, you'll never get anywhere, right? If you gave them a sequence of ops that was even 3 or 4 lines to at least get them to say, yes, that looks good to me, it's at least a starting point. And there's still enough people that don't even ask that we get ourselves in trouble. Even without color tuning, people are not asking that question. So the problem is to your point, even that much greater because of the variability of what you can do with color tuning.
Yeah, technically, we've run out of time, but we'll go with another.
I have a few feedbacks as far as the questions that have been answered or you've had been asked, and then I also want to ask you a question, Eric, as well. But based off of just the cost of the devices, what we've learned in the past is we'll actually ask the programmer to come out on site when we're out there commissioning and testing the system. And if they actually have a meter that they're utilizing during programming, they should be able to also utilize that while you're out there on site to help verify that lights are changing according to the sequence. Now, as far as sequence, I know most of the time, as far as my experience, owners truly don't know what they're looking at when you're asking them about color temperature. And we have in the past asked that the contractor and the lighting controls programmer come out on site with the owners and the maintenance team and the staff, whoever needs to be involved. And we do a mock-up of one room, and then from there we kind of refine some of the spaces. And as far as that, it just really gets down to really fine-tuning some of that. So that's what we recommend, and that's also what our firm does.
It's a good example when you get into some of the spaces like hospitality, because you can do different rooms. One could be a king, one could be two queens, but there's going to be multiple of that same room type, and it's a great approach because you can use one as a baseline and implement it from there without having to have everybody involved.